Okay, students. So let us continue to the next question. So right now we have discussed about the 13th question, and the answer what we get at the end is 3 meter per second. That is a velocity. And let us continue. Let us get back to the 14th question. Question number 14. So what that is question number 14 says. Let us see. They have mentioned one graph. The graph is like this. Fine. And whether it is a VT graph? No, it is a AT graph. Be careful while discussing. We are mentioning which kind of graph it is. So note down that. So it is 10 meter per second square it is written, and the value over here it is 11 seconds it is written. And now the particle starts from rest. It accelerates versus time as shown in the figure. The maximum speed of the particle will be. Maximum speed of the particle will be, they have asked. That means area under AT graph. Area under AT graph gives you what? Velocity, right? So area under AT graph. So area will be equal to what? Equal to half into base into height. So this is 55 watt meter per second. Very simple. But look at the graph carefully. You should be knowing what kind of graph, what is the meaning of different XT graph, VT graph as well as AT graphs. So individual importance of all those graphs, suppose you know, means it will be very easy to solve such kind of questions. So we got 55 meter per second, and the option is, that is B. Fine, then let us go for the question number 15. Question number 15. I will read the question. A ball is dropped vertically from the height D above the ground. Okay, so let me draw the diagram. The diagram in the sense, simply one rough diagram I will take. A ball is there. The ball is dropped vertically from the height D. So let me take this height as D. Vertically it is dropped, okay, on the ground. It hits the ground and bounces up vertically to a height D by 2. So soon after it bounces back, no, it will rise up to a height of D by 2, okay. Bouncing back, you know that, rebound, okay. When the object, when it is under free fall, it hits finally on the ground and it bounces back. But this one reaches to a height of D by 2. Fine. Neglecting the subsequent motion and air resistance, its velocity v varies with the height h above the ground as. So right now, what kind of graph we require here, velocity versus height. How it varies, how it covers the distance, in a sense like hitting, bouncing back in that case. So now what we have to observe very carefully here is, when an object comes in a downward directions, displacement is taken negative, velocity is taken negative, g is always negative. When object is moving in the upward directions, that means in Cartesian coordinate system, suppose you mention means it will be taken as a positive y axis. So here displacement v will be mentioning it is positive, velocity we mention it is positive, but g always negative. Why? Because it's always directed toward the center of the earth. That is why we have to assume like that. Various type we can take. It's okay, fine. This is the standard form which we follow. Now what I do is, I will just search the graphs. I will just draw the graph. One graph was like this. Okay, that is velocity versus height. And then one is like this. One more is there. I will just explain, okay, how the graph can be explained. Here h, here v, here also. It is coming like this. It's coming in this way. D. Of course, we can make out this is D by 2 then, right? Yes. So this is V, and the last graph is like this. That is 1 and one more. What is that? The direction is something like this. Okay. So these are the graphs which is available in that question as options. Now, when object is dropped, what happens to the displacement? D. D is increasing, of course. This height is there, correct? From the rest, it starts increasing in the negative directions. So D value becomes 0 when it reaches the ground, correct? Yes, of course. From here, if you consider negative directions, total that means height D is taken. From the highest value, it is dropped. So when it reaches ground, becomes 0. From the highest value, in which direction? Negative direction. See, this graph has reached here. Fine. After bouncing back, what happens? The object goes up. What happens? Displacement will be in positive directions. But how it varies? It varies in the curvature path over here like a parabola. So positive direction it varies. So look at here. Hits the ground, bounces back. To what height? Half of D. That means this particular point will be D by 2. This is actually acceptable graph. Let us compare other graphs also if you have any doubt means. Here, D varies from 0 to maximum D. No, nothing is sent up. It is actually dropped. This is not possible. What about this one? Look at here. From 0 to D negative value. No way. This one is actually, because direction depends here. Direction. So what we can say is, this will be the, because height, highest. That is why it is V versus H. It is not V versus T graph. In order to something like confusion is there means it is just make sure it is not VT graph. It is some variation of two physical quantities. And what are those physical quantities are? That is velocity as well as height variation. So these are the points you should be remembering. So careful observation. Suppose you have got on this one means you can understand it easily. So that is all about question number 15. So let us continue for the question number 16. The question number 16, let us see. Question number 16 is, if vector A is equal to B plus C. It's all about. So question number 15. So 15, motion in one-dimensional concepts we have discussed now. Let us go to the next concept, it is vectors. Some of the questions we'll discuss. So vector A is equal to vector B plus vector C. So vectors concepts you know, and what and all the properties of that one. Commutative, associative, all those, okay. And vectors cannot be simply added up because there are certain rules are there. What are those rules are? Like some laws we have to follow. Like triangle law of vector addition, parallelogram law of vector addition, polygon law of vector additions, like that. So we have to follow some rules. We have to add their magnitudes. So some rules, that means some set of rules are there. So we have to wait. So right now, A is equal to B plus C, it is mentioned. So what is the meaning of this? A can be, or B, sum of B plus C, two vectors can be replaced by a single vector. So if I take, whether they have given the values there, yes, of course. A is 5, B is 4, C is 3. A is actually the resultant of what? B plus C, right? So B I will take how much? 4. Vector B, magnitude is how much? 4. This is one vector acting at one direction. And one more vector is there, that is C. If you add those two, you have to get what? A. So now what I do? I'll take one more vector. Vector C is equal to how much? This is equal to 3. And they are equal to A. Understanding, right? Like this. It's magnitude of this one. So A is equal to how much now? Magnitude of vector A, that is 5. Now what you are supposed to do is, the given options which are there, okay? Options are not in numerical values. They are in something like trigonometric ratios they have given. So we have to find out what is that. Now, what I do is, I will just rearrange this particular vector combinations, okay. So we require to find out some angle because in the options you can see there. So how to find out angles here is, A acts as a resultant. So I will just retrace that graph once again. This is B. This is A. Sorry. This is C. This will be the A now, resultant. Okay. This will be the angle. So angle what I can take there, whether they have mentioned any concepts, this one. So I'll just take whatever. Okay, it can be, okay, what is that? Resultant, what they have mentioned, what is the angle? So that means with the C it is actually mentioned, not with the B, the angle is with the C. So how much is the angle? I will take theta. Hope it's clear for you people. With the C, how much angle it is, because I want this angle, okay. That is why I have taken like this. Hope it is clear for you people. And you can either go for the next one also, but substitution will become slightly different, that is it. Now I will go for this particular set now. So here you can see this particular vector, and this can be drawn like this. If this becomes theta means this becomes what? This becomes vector B. Am I right? Opposite side becomes vector B. What about this one? This one becomes A. Base becomes C. Compare these two. I have drawn in different geometrical shape. Now what we have to do? We have to write down the values. What are the values now? So B is equal to how much? 4. C is equal to how much? This is I think 3. A is equal to how much? It is 5. So after finding out this, what I do is, I know what is opposite side, hypotenuse as well as adjacent side, and by looking at the answer you can see 3 by 5, 4 by 5, 3 by 4, something like that. But what are the trigonometric ratios I can find out? I don't know. Some cos function is there, sine function is also there. So I will just go for all kind of trigonometric functions. That is, I will go for first tan theta equal to how much? Opposite side by adjacent side. What is that? 4 by 3. And theta equal to what? Tan inverse of 4 by 3. Whether this option is there? No. I will go for sine. Sine theta equal to opposite side by hypotenuse, that is 4 by 5, or theta equal to what? Sine inverse of 4 by 5. Whether this option is there? No, it is sine inverse of 3 by 4, which is wrong. So ultimately I go for what? Cos. So cos inverse of, how much it will be cos inverse of? In the sense, adjacent side by hypotenuse. So it will directly, I will write down 3 by 5. So cos inverse of, theta equal to cos inverse of 3 by 5. So the option is there, and that option is 16th one. It is option A. So have a look what I have done there. They have given, this looks very simple, but when you start solving that, you should be very careful, because the option only help us to assume in what way we have to substitute for this kind of numericals. Without seeing options, we cannot make out. Our answer should be done in this particular way. So we have to search all possible by using basic trigonometric functions. I have checked. One of the answer I can come across is, that is only theta equal to cos inverse of 3 by 5. That is about the question number 16. So question number 17, let us go for. Question number 17 is, the following sets of 3 forces acts on a body whose resultant cannot be 0. In the sense, you can see there different sets of forces, 10, 10, 10, 3, 10 force, 10, 10, 20, 10, 20, 23, 10, 20, 40, like that. Different vectors are acting at a body. And you know, if there are 3 vectors are acting at a body, means what we are supposed to do? First take 2 vectors, take the resultant. So those 2 vectors will be replaced by 1. And then again, 1 more will be there. So you have to find out the resultant. For example, imagine like this. This is F1, F3, F2. Basically, suppose this is point P. Now what I do is, I will take these 2 vectors. What is that? F1 and F2. So like this, or you can replace that one. So F1, F2 angle is 90 degree. The resultant will be in some directions in this way. Correct. So already F2 is there. This will be having some angle, that will be resultant. Like this, 2 new vectors will be there. Again the resultant will be in some other directions. Like this. diagram, I think it is clear for you people, you can make out. So like this we resolve the vectors, correct? So now what we do is, here you can closely have a look there. Combination of 10, 10, 10, 3 times, 3 vectors acting at a point. Whether it is, resultant cannot be 0, it is asked. Okay, resultant cannot be 0. That means, suppose the vectors change their directions also, the resultant shouldn't be 0. Resultant cannot be 0 means one by one we are supposed to do the combinations you have to check. So ultimately what we can say is, just let us add up something. Okay, for example, you can see there, first one, 10 plus 10 equal to 20, correct? In the first options I am just simply writing 10 plus 10 again. So what you can see there is 3 options are there. In 3 options 10, 10, 10 is there. In that one, what I do, 2 vectors I have added up, gives you what, 20. And you can see there, it is actually a normal what kind of, here you can check by using the magnitude forms and all, you can check. And the second one, suppose I add up 10 plus 10 equal to again 20. The condition is, here third one, just simply roughly I am doing 20 equal to 30. The last one you can see there, fourth option, 10 plus 20 equal to 30. Whether it is possible, because the whatever the value of third vector is there, no, the resultant, that should be always equal to or more than that of the third vector. In this case, whether 20 is greater than that of 10? Yes. In this case, whether it is greater than or equal to 20? Yes. Third case, whether it is greater than or equal to, how much is that? 23? Yes. Hope it is clear for you people now. One particular case we have mentioned here, like this. So 10 plus 10, 20, which is greater than that of the third force, 10. So we can accept this. In this case, it can be 0 or not. Here also it can be 0. Here also it can be 0. But in this case, it cannot be 0. Why? Because 30 is not equal to or more than that of 40. In this case, we can say, what is that? This is how we can find it. Okay, the resultant cannot be 0 in only one case. What is that? Fourth one. Either by changing the direction. For example, A plus B, and if you just reverse the direction of B, it becomes minus. So those, if they are exactly in opposite directions, we can say they can cancel each other. But in this kind of combinations of forces, if the third vector has got the value very less than that of, that means much greater than that of the third, that means the answer, magnitude of that, in the sense by adding the vectors, this cannot be happening. So in this case, what happens? That is, the resultant cannot be 0. In all other cases, it is possible. That is the combinations. Okay. In such kind of combinations, you can try by using the resultant formulas. You know how to use resultant formulas with proper angles. But to check whether the resultant can be 0 or not, remember, this is the step. What is that? Just add 2 vectors, look at the value and check with the third vector. Here also, check the third vector. Condition is what? Should be, the sum should be greater than or equal to the third vector. Like that you check. Last one is not having the proper, yes, what is that? Condition is not greater than or less or equal to, okay, not greater than or equal to 30. That is why here resultant magnitude cannot be 0 in this case. In all other cases, it is possible. That is a explanation. Okay, fine then. Now let us go for question number 18. Resultant of n forces of different magnitudes acting at a point is 0. Okay, the resultant of n forces, maybe 2, 3, 4, whatever. The minimum value of n is At a point, if resultant is supposed to be 0 means what should happen? One vector should be here, one vector should be here. That means 2 vectors minimum is required. So n should be equal to 2. It's not a very difficult kind of question. Common sense it is. That means basic knowledge. How many vectors are required to make the resultant 0? Minimum 2 vectors. That means they should be having the same magnitude and they should be in the opposite directions. Question number 19 says vector C is equal to vector A plus vector B. Hope that 18th one is clear for you people. Minimum 2 vectors are required. We should be placed in opposite directions having the same magnitude. Question number C says let C equal to vector A plus B. Which of these things, okay? It means the options it is mentioned. Vector C is always greater than vector A. Of course, because it is resultant, correct? Vector C always should be greater than that of what? Vector A, because vector addition is happening here. Next, it is possible to have vector C less than or less than A and less than C less than A, but C less than B. Individually, suppose you check. C is always equal to A plus B, that is also correct. C is never equal to A plus B. That means what we can say from this is, you can see the options carefully. Magnitude of C is always greater than that of magnitude of A. It's just magnitude, not the directions. Yes, of course, we can accept that. What about C? It is possible to have magnitude of C. Yeah, it is possible. If you change the directions and all, it is possible. Therefore, magnitude of C is less than magnitude of A. Also possible what? Is less than magnitude of B. So these two are okay. It's possible to have like this kind of case. So what about the next remaining options? C is always greater than A. Yeah, we cannot say, because of course correct, it can be greater, but whether it is strictly followed that it should be always greater than C. So it's a correct only, but always we cannot. And okay, that means say that C is never equal to A plus B, not possible, because it is says it's a vector addition, and C is always equal to A plus B. In this case, if you take magnitude, it is fine, but regarding directions and angles, we cannot say that. So ultimately the options which is possible here is option B. And then we'll go for question number 19 over, that is question number 20. Question number 20 says that force of 1 and 2 newtons acting along the line x equal to 0, y equal to 0. Okay, fine. Equation of the line of action, they're asking. 2 forces are there like this, 1 Newton, and here it is 2 Newton. Now what they are asking, equation of the line of action of resultant will be here, correct? Yeah, like this. Now resultant, you know, with what angle? With the adjacent side, I will take theta here, okay? So that is what they are asking now. So this is y direction, x direction. Then what else they require? Equation. So see, look at there, equation is in a different form, it is given. Now how to get these particular equations? So force it is mentioned. What I do is, I will just simply take the values. What are those values? So see, if you just consider this one, it's a right angle triangle, tan theta equal to what? Y divided by x. How much is y? 1 Newton. How much is x? 2. Correct? Next, this much we get. So by looking at this one, what I can write? 2y equal to x, or 2y minus x equal to 0. Let us check whether it is present in the given option. Yes, it is there. That is 2y minus x equal to 0, it is there. So option is B. So think you understood about the questions. These are actually just knowledge based questions. This one, and this one you have to just substitute. You just have to try by just using some basic trigonometric functions. Here it is knowledge based. Here also it is memory based. Okay, all this. So you should remember the theory. So directly you can answer this, where we much more classification as well as explanation along with the diagrams is not required. Done. Next, question number 21. Question number 21 says, two balls are rolling on a flat surface. One has velocity component 1 meter per second and 3 meter per second along the rectangular axis x and y respectively, and the other has component 2 meter per second and 2 meter per second respectively. If both the balls starts moving from the same point, the angle between their directions of motion is. Hope the question is clear for you people. Now what we're going to do is, there are two balls, okay, starting from the same point. Their components are given in x and y direction. First ball, components I will draw. Ball 1. Its components is mentioned, okay. How much is that magnitude which is mentioned there is, one is 1 meter per second and one more is how much? √3. Of course, the resultant, you can understand, we don't know with what angle. I will write theta 1. Next I will take ball 2. What are the components? 2 meter per second. Okay, 2, 2. Resultant, angle theta 2. Theta 1, angle theta 2. Like this I have taken. Now what I am supposed to do is, we are supposed to find out, they are starting from the same point. Now resultants are in the different directions. So one has got one theta 1 value, one more has got theta 2 value. What they are asking, if both balls start moving from the same point, the angle between their direction of motion is. That means maybe theta 1 is like this, alpha equal to how much? This is what they are asking, okay. So now what I am supposed to do, first let us find out what is theta 1. So tan theta 1 is equal to how much? √3 by what? 1. So theta 1 equal to tan inverse of √3 means how much? √3 means 60 degree. That means theta 1 is 60 degree. What about that? Tan theta 2 equal to 2 by 2 equal to 1. That means theta equal to 45 degree. I am just finding out the angles, okay. I am just finding out the angles. That angle only will give us the information about, in both cases, balls in which direction they are going to move, and the difference between them will give you the final answer, okay. So theta equal to what? Theta 1 minus theta 2 equal to 15 degree. So option you can see there, option is 15 degree. Next, 22nd question. So 22nd questions, that is, let us check.